In this section, we'll be learning about special matrices. Special matrices are square matrix, that is their dimension is n cross n or n by n. For example, if it is 5, then it is 5 cross 5. 5 rows and 5 columns. So matrices are square matrix. This is the first thing. And the second thing is they are having more number of zero elements. If there are more number of zero elements, then we can handle them specially and store only non-zero elements and avoid storage of zero elements, so that space can be saved as well as computation time can be saved. So we'll be learning about all these matrices one by one. I'll just read out their names, that is diagonal matrix, lower triangular, upper triangular, symmetric matrix, tridiagonal, band matrix, Toeplitz, and at last we'll learn about sparse matrix. So let us start with diagonal matrix. This is a diagonal matrix. I have taken a diagonal matrix of order 5 by 5, that is 5 rows and 5 columns. And here you can see that most of the numbers are zeros and only the elements in a diagonal are non-zeros. So the important thing is, other than diagonal, all elements must be 0, then only we say it's a diagonal matrix. Suppose I have some element here, let us say 5, then it's not a diagonal matrix. This must be 0. So the important condition is all those elements must be 0. So let us see how we can define this one. See, if this is a matrix M, then M of ij is 0. If I is not equal to j, M of ij should be 0. If I is not equal to j, then it is a diagonal matrix. If they are equal, then the elements may be 0, non-zero. We don't bother about that. We bother about rest of the elements. All these elements must be 0 and these elements are 0. So these elements are non-zero elements, rest of the elements are zeros. So I have given a definition of diagonal matrix. Now, if I have to represent a diagonal matrix in a program, then for a matrix I have to take two-dimensional array, 5 rows and 5 columns. But if I take a two-dimensional array of size 5 by 5, most of the elements will be zeros. So I'll show it. So like this, if I take a two-dimensional array for storing this matrix, then most of the elements are zeros. If these are integers and integer is taking 2 bytes, then total how many bytes of memory this array is consuming? There are 5 into 5 elements are there, that is 25 elements are there, and each element is taking 2 bytes. Suppose for an integer, then it is taking 50 bytes. 50 bytes of memory it's consuming. So if I am storing this in 50 bytes of memory, then storage of 0 elements is unnecessary. So it is wasting space. As well as when I am processing on diagonal matrices, like if I am adding 2 diagonal matrices, then adding of zeros is of no use. If I am multiplying 2 diagonal matrices, then multiplication with zeros is of no use. So I will be wasting time in processing upon zeros. So the idea here is that we want to store only non-zero elements. So how we can store only non-zero elements? So for only non-zero elements, we can take just a single dimension array and store these elements. So let us see how we can do that. Now let us see how we can represent a diagonal matrix in just a single dimension array. So I will take a single dimension array, let us say A of size 5, because only I have 5 non-zero elements. So I have an array of size 5. This array starting index is 0, but here if you observe, I have taken the indices from 1 onwards. So in mathematics, we start indices from 1 onwards, so that's what I am following. So if you want, you can change the indices from 0 also. Then this array, that is in programming, it is in C programming or in C++ programming, the array starts from 0. So I have taken an array from 0. Now I want to store only non-zero elements. So let us store those elements. 3, 7, 4, 9 and 6. So I have stored only non-zero elements. Now let us see how we can access these elements from a single dimension array. If I want to access m of 1, 1, this element, then it is at 0. If I want to access m of 2 comma 2, this element 2 comma 2, it is at 1. So only diagonal elements are there. So if I want to access any element from matrix m of I comma j, this I am calling it as m, but it is stored in an array. Then from where I can get the element? First of all, if I is equal to j, if I is equal to j, then only we have an element, right? So if I is equal to j, then 2 comma 2 is present at 1, 3 comma 3 is present at 2, so element is present at I minus 1, or even I can say j minus 1. So this is very simple. Now we will see how we can write a C program code for representing this one. So I will write down just required code for implementing this diagonal matrix using C language. So for that, first of all, I need an array. A of what size? For my example, it is 5. If you want, you can also take a dynamic array of variable size, whichever size you want. At runtime, you can create a dynamic array. So I am not writing a complete program, just I am showing you the pieces of code. Now, for storing data in a matrix, that is this matrix, or retrieving the data in a matrix, that is actually in a 1D array, I need two functions, that is for setting the data and getting the data. So set and get functions I need. So let us write first set function for saving data or storing data in this one. So first of all, it needs array. First parameter is array. Which array? See, in my program, I may be having many matrices which are diagonal matrix. So whichever the diagonal matrix is, I can pass it as parameter. Then next, it needs which element? Suppose this element. Along with this, it also needs row number and column number, that is I and j. So three more parameters are required, that is I, j, and x is the element that I want to store. So these are the parameters of a function. First of all, an array in which you want to store what is the row number, what is the column number, and what is the element. Now, if I am giving any element for storing this one, then actually it should be stored in this array that is being passed as parameter to this one. So before storing, first of all, check whether I and j are equal or not. So store only if they are equal. So if I is equal to j, then only set function will store the element. Where it will store the element? In an array, it will store the element at I minus 1, that is assigned with x. That's all. If I is not equal to j, do nothing, no need to do anything. So close this one. See, this is the formula just now we have seen that how we can access the elements, that is I minus 1. So this is set function. Now I need a function for reading the data or retrieving the data from some row number and column number. So for that, I will write a function called get. And this also needs an array, and it needs indices I and j, that is row number and column number, and it has to return the element. So whatever the element we want to retrieve, it has to return the element, so the return type is integer. Now inside this, I have to retrieve an element. So whatever the I and j values are given, from there it has to retrieve an element. But first of all, it should check whether I and j are equal or not, because we have the elements only for I is equal to j, that is diagonal. So check if I is equal to j. So I will write in the same line, if it is equal, then return a of I minus 1. So it is at the same place where I have stored it. Otherwise, if it is not equal, then definitely the element is 0. So return 0. These are get and set functions we can write down and call them from our main function or from anywhere in the program. But we also have to pass the array in which the diagonal matrix is stored. So while writing the program, I will be writing a complete program and show you. In this video, we will write a C program for diagonal matrix. So I will start a new project, and the project name I will call it as Matrices. I'll select the language as C language. Next, create a project. Project is ready. And here is the main function. I will hide these panels. Now the complete program is here. As we have discussed already on whiteboard, for implementing a matrix, we need a single dimension array for storing the elements, the only non-zero elements, and also its dimensions, that is n. So I will define a structure for these two things together. I'll call the structure name as matrix so that it is useful for all type of matrices. First of all, we need an array of some size. So I will take an array of size 10 right now for a diagonal matrix. See, I am taking a fixed size array. You can create an array dynamically in a heap. We already know how to create a single dimension array in a heap. So you can take a pointer and create an array. But for explanation purpose, I am taking a fixed size array. Now this is a diagonal matrix. Here inside the main function, I will create a variable of type matrix M. And let us set the dimension of this one as 4. This is 4 by 4 matrix. Now I will write on the functions that we have discussed, that is set and get function. So first function I will write on set. Set, it should take a matrix as a parameter. The parameter name I will give it as M only. Then it needs I and j value. What is the index at which you want to set the element? And last thing is, what is the element you want to insert? And it's going to modify the matrix, so it should be called by address. So I will take a pointer. Then as we are going to store only non-zero elements, then we should check whether the indices are equal or not. If the indices are equal, then we will set an element x at that particular index. Now m dot a of, I can either use I minus 1 or j minus 1, anything, and there I should assign the variable x. So if I is equal to j, then only the value will be set, otherwise nothing will be stored, means zero elements are not stored. Now next I will write a function for get, which returns an integer value. It needs an array matrix, that is m, parameter I am giving it as n, then it needs indices I and j. So it returns the element at that particular index. This should also return the value if I is equals to j. So first thing, check if I is equal to j, then we can return an element. So return an element from array of I minus 1. Either I can write I minus 1 or j minus 1. Otherwise, element is not there means it is 0. If it is non-zero element, then this a of I minus 1 will send, otherwise 0 will be sent. Element is 0 type. Then I will write one more function for displaying this matrix. So function name is display. Then it should take matrix as a parameter. I need two variables for running two for loops because it should display it as two-dimensional array. So using for loop, I will display for I assign 0 and I is less than m dot n I plus plus. Then for j assign 0, j is less than m dot n and j plus plus. And in this for loop, I should print the value only if I is equals to j. Then I should print f percentile d, I'll give some space, that is m dot a of I minus 1 element. Otherwise, I should print 0. Just 0 with a space. Then after the end of inner for loop, that is after the end of a row, I should print new line. That's it. This is a display function. Now from the main function, I will call set function and set some values that of a diagonal matrix. Then I will call display to show you the matrix. So here I will call set function and set the values. First of all, 1, 1, I will set the value 5. In the same line, I will write down pass array, and 2, 2 also I will set the value, that is 8. Likewise, I will set one more value, 3 comma 3, and the value is 9. Then at 4 comma 4 also I will set the value is 12. So I have set some values. Now let us display this matrix. Let us run the program. Yeah, here we got a diagonal matrix, that is the elements are non-zero only inside the diagonal, rest of the elements are zeros, because I am printing here 0 values, right? If the I value and j value are not equal, if I and j values are equal, I am displaying m of a of I, right? While storing, I am giving the indices starting from 1 onwards. So while storing, I am taking I minus 1 or I minus 1 when I am retrieving. But for displaying, I am starting from 0 onwards, so I have taken only a of I. If I have to use the same formula I minus 1, then I should start this from 1 onwards. I assign 1 and j assign 1. Now let us call a function get and get the value at some location. I will directly print the value get %d and new line. I will get the value at a location 2 comma 2. So it should give me value 8. So it should print 8. Yes, it is printing 8. Then after that, display function is displaying all the elements of a matrix. So that's all. Anywhere inside your application, if you need a diagonal matrix, then you should have a structure and these supporting functions for a matrix. And if at all you need to display the matrix, then you can have display function also. Otherwise, for looking at the output, we are using this display function. So this may or may not be required, but set and get functions are more important for this matrix. So this is the implementation of the matrix. Now, for the following matrices also, the same thing we will do. Only the difference is you may have to change the size of this array and the formulas will change. So for rest of the matrices, it will be a student exercise. That's all with this matrix. This is a diagonal matrix. I have taken a diagonal matrix of order 5 by 5, that is 5 rows and 5 columns. And here you can see that most of the numbers are zeros and only the elements in a diagonal are non-zeros. So the important thing is, other than diagonal, all elements must be 0, then only we say it's a diagonal matrix. Suppose I have some element here, let us say 5, then it's not a diagonal matrix. This must be 0. So the important condition is all those elements must be 0. So let us see how we can define this one. See, if this is a matrix M, then M of I, j is 0. If I is not equal to j, M of ij should be 0. If I is not equal to j, then it is a diagonal matrix. If they are equal, then the elements may be 0, non-zero. We don't bother about that. We bother about rest of the elements. All these elements must be 0 and these elements are 0. So these elements are non-zero elements. Rest of the elements are zeros. So I have given a definition of diagonal matrix. Now, if I have to represent a diagonal matrix in a program, then for a matrix, I have to take two-dimensional array, 5 rows and 5 columns. But if I take a two-dimensional array of size 5 by 5, most of the elements will be zeros. So I'll show it. So like this, if I take a two-dimensional array for storing this matrix, then most of the elements are zeros. If these are integers and integer is taking 2 bytes, then total how many bytes of memory this array is consuming? There are 5 into 5 elements are there, that is 25 elements are there, and each element is taking 2 bytes. Suppose for an integer, then it is taking 50 bytes. 50 bytes of memory it's consuming. So if I am storing this in 50 bytes of memory, then storage of 0 elements is unnecessary. So it is wasting space. As well as when I am processing on diagonal matrices, like if I am adding 2 diagonal matrices, then adding of zeros is of no use. If I am multiplying two diagonal matrices, then multiplication with zeros is of no use. So I will be wasting time in processing upon zeros. So the idea here is that we want to store only non-zero elements. So how we can store only non-zero elements? So for only non-zero elements, we can take just a single dimension array and store these elements. So let us see how we can do that. Now let us see how we can represent a diagonal matrix in just a single dimension array. So I will take a single dimension array, let us say A of size 5, because only I have 5 non-zero elements. So I have an array of size 5. This array starting index is 0, but here if you observe, I have taken the indices from 1 onwards. So in mathematics, we start indices from 1 onwards, so that's what I am following. So if you want, you can change the indices from 0 also. Then this array, that is in programming, it is in C programming or in C++ programming, the array starts from 0. So I have taken an array from 0. Now I want to store only non-zero elements. So let us store those elements. 3, 7, 4, 9 and 6. So I have stored only non-zero elements. Now let us see how we can access these elements from a single dimension array. If I want to access m of 1, 1, this element, then it is at 0. If I want to access m of 2, 2, this element 2, 2, it is at 1. So only diagonal elements are there. So if I want to access any element from matrix m of I, j, this I am calling it as m, but it is stored in an array. Then from where I can get the element? First of all, if I is equal to j, then only we have an element, right? So if I is equal to j, then 2, 2 is present at 1, 3, 3 is present at 2. So element is present at I minus 1. Or even I can say j minus 1. So this is very simple. Now let us write a C++ class for a diagonal matrix. So let us take a class name as diagonal. Class diagonal. What are the data members or the properties required for a diagonal matrix? I need a dimension. What is the dimension? And an array space for storing the element. So let us make the data as a private. Two things I need. One is dimension n. As it's a square matrix, so just n is enough. We don't need n cross n, mn. We don't need just one dimension. That is same square matrix. If n is 5, it is 5 into 5. Then we need an array. For this array, I will not create an array, but I will take a pointer so that I can dynamically create an array. That's all. These are the two things I need. The next thing I should write on a constructor. So constructor inside public. I will write a constructor for diagonal. So when you are creating an object of this one, then what we need? We need the dimension, whether it is of size of 5 or 4, whatever it is. So I need a dimension. So let us take int n. So this will take a dimension. Then inside the constructor, I should set this value n to this one and also create an array. So here this n, so this arrow n assign with this parameter, and to this a I should create an array of the same size, this size. So new, if I am taking integer type here, then it is integer only, integer of size. I can simply write n also. So I can use either this one or this one. So this is how array is created. So we will get a single dimension array of required size. That is 5 means array of size 5. Let us say this is the 5 size array. Then what are the other functions I need? I need functions for storing the data and retrieving the data. So for that I need functions like setting the data and getting the data. So I will write on those two functions. Void set. So this set will store the data in this array. That is for this matrix. For a matrix, I need to know the row number and column number. So row number and column number as well as element. So it needs 3 parameters. at which row and at which column, what is the element that you want to store, x. Then we need a function for retrieving the data. So the function name, let us call it as get. Then it also needs from which row number and which column number you want to retrieve the data, and return type should be integer because it's going to return the element at that row number and column number. Then we will also have one function for displaying a matrix. So I will write a function called void display. So instead of a display function, we can also overload insertion operator. That I will show you when I write the program. Now last thing is we should have a destructor for destroying this dynamically created an array. So here I should also have a destructor diagonal. That's all, end of a class. Next I will implement these functions outside the class using scope resolution. So here I will write on those functions. First function is set. So void class name diagonal set 3 parameters I, j and x. Then what it's supposed to do? When 3 parameters are given, row number and column number and the element. So if I am giving suppose 9, so I will be giving 4, 4 and 9. If I am giving 7, then 2, 2, 7. Even I may give 3, 2, that is 0. So it should not store 0. So first of all, it should check whether the indices are for diagonal only or not. So if I is equal to j, then it should store the element in A of I minus 1. This is the formula we have seen. Like this is 1 comma 1 is stored at 0. So 3 comma 3 is stored at 2. So I minus 1. I comma j is stored at I minus 1. If they both are equal, so store the element. That's all. This is set function. If they are not equal, don't do anything, don't store anything. We don't have to store anything in the array. Then second one is get function. Return type and the class name. Next is get 2 parameters I and j. That is which element you want to read, which element you want to retrieve. Suppose I want to retrieve 3 comma 3. So 3 comma 3 means at index 2. That is 3 comma 3 is 4. This one. So I comma j is given. Now here again I can get the data from there only if I is equal to j, just like in set. Same thing we have to do. If I is equal to j, then in the same line I am writing return A of I minus 1. And one more thing, if they are not equal, then definitely the element is 0, so return 0. So these are set and get methods. So I have a constructor, I have set method and get method completed. Now I will write down these two functions. There is no space. I will remove this and I will write down those two functions. Now display function, class name and function name display. Display means actually we have these elements, but we should display it like a two-dimensional array along with its zeros so that it looks like a matrix. So let us display a two-dimensional matrix. So for that we need two for loops. For I assign 0, I is less than n, I plus plus, that is that n. And for j assign 0, j is less than n, j plus plus. Then I have to display the elements. But how many elements I have? Only diagonal elements that are present in the array. So I should display the element if I is equal to j. Otherwise I should display 0. So if I is equal to j, so in the same line I will write down cout A of I minus 1. Otherwise cout 0. So whatever you want to display, you have to give it in double quotes if it is not a variable. So I want to display 0. So 0 is given in double quotes as a string. Then close this one. This for loop will display one row, and after every row I should go into the next line. So cout and L. Then close for loop and close the function. So this function using two for loops will display a two-dimensional array like this. Then I have this last function, that is destructor. It should have just a simple statement, so I'll explain there only. Just I have to say delete this array A, the one that is dynamically allocated, it should be deallocated. So just as a single statement inside that function, so I have expanded there itself. So that's all for our diagonal matrix. We'll be learning about more matrices like lower triangular and upper triangular. In all those matrices, we will be having same set of functions in a class. I will not be writing a complete class every time. Then we have to see the other matrices like lower triangular and upper triangular and so on. For every matrix, the class looks similar. We will be having dimension and RR square matrices, and we'll be having array space, and we'll be using single dimension array only. And we need a constructor, set and get function, and display and destructor. And while writing a program, I will show you a complete class. In this video, we'll look at a program for diagonal matrix using C++. So I will be defining a class for diagonal matrix. I'll create a new project here. I'll call the project name as Matrices CPP. Now the project name selected is Matrices CPP and the language is C++. Next, let us create the project. Project is created and this is the main function. Now we are ready. As I have explained you on whiteboard, I will define a class for diagonal matrix. Now inside the diagonal matrix, the data members that we need are an array. For that I will take a pointer and the dimensions. Now inside public, the very first thing that we will write down is a constructor. Diagonal constructor, first of all I will define a non-parameterized constructor. So here I will create a I will take minimum dimensions as a 2 for a diagonal matrix, that is 2 by 2 matrix, and array I will create of size 2, int of size 2. Means if size is not given, then minimum we will create an array of size 2. Then otherwise we will have a parameterized constructor, and inside this we will first set the dimension n, assign n. What is this n? The first n is this one and the second n is this one. So how to differentiate that? So we have to use this pointer and we can differentiate. So this means this n, and on the right hand side what the n is given, simply n is given, so that is a local parameter. Then we should create an array of size n. I'll hide these panels. Now the constructor is ready. As we are dynamically creating an array from heap, we should also have a destructor. And this destructor should delete that array when object is not in use. So the first function we will write is set, which will not take array because it's directly inside the same class. It needs I and j and the element that we want to set. Then I should have a function for get, which will return an element from a given index, so I should pass int I and j. Then I should also have a function for display. Now these functions I have to implement them outside the class using scope resolution. So first function is set. So this is diagonal matrix and the function name is set. It's taking 3 parameters. Now the procedure is same. If I is equal to j, then only we will set an element in a array at I-1 location. Otherwise we will not set anything. The next function is get function, which will take two parameters I and j. And this will also check if I is equal to j, then it will return an element from array at index I minus 1. Otherwise, it will return 0. Then we should have a function for display. Display function, which doesn't take any parameters. It needs two for loops for displaying all the elements. For I assigned 0, I is less than n, and I plus plus. Then for j assigned 0, j is less than n, and j plus plus. Now here, if I is equal to j, then only we have an element in a diagonal, so I should display cout element from a of I, and I should give some space. Otherwise, I should print 0 and also with the space. And at the end of inner for loop, I should say cout and L for the new line. That's all with the display function. Here IO stream is included, so we should use namespace. So using namespace std. Now, inside the main function, I will create an object of diagonal matrix D of dimension 4. I will call set method and I will set a few elements. That is, first is 1, 1 and the value is a 5. Inside the same line, I will write down. Likewise, I will set other elements. D dot set 2, 2 is 8. Then D dot set 3, 3 is 9. Then D dot set 4, 4, as we have given the dimensions as 4, value is 12. Then D dot display. Now let us run the program. Yes, we got a diagonal matrix. Display function is displaying all the diagonal elements. Rest of the elements are zeros. And the values that we have set are 5, 8, 9, 12. So they are appearing in the diagonal. So that's all with the C++ program for diagonal matrix. I have written a complete class for diagonal matrix. Now all other matrices also look similar. Only the name will change and the size, depending on their required size, you should create an array of that size. And also get and set functions will change. I think display function will look similar, only the difference may be the condition may change. So rest of the programs will also be similar. That's all, we stop here. The next topic is lower triangular matrix. A lower triangular matrix is a square matrix in which the lower triangular part of a matrix is non-zero elements and the upper triangular part is all zeros and none of them is non-zero. So you can see this one, these set of elements are non-zero. These are forming a triangle. Now let us define this and see which elements are 0, which are non-zero. Let us check the indices. If the name of this matrix is M and these are rows and let us call them as I, and these are columns, let us call them as J. These are columns and call them as J. Now if I compare I and J, this is 1, 1, 2, 1, 2, 2, 3, 1, 3, 2, 3, 3. So if you check all these indices, I value is greater than or equal to J value. So for non-zero elements, I value is always greater. Then what about zero elements? I value is smaller. So it means if I value is less than J, that is row number is less than column number, then the element must be 0. These must be 0. So we can define a lower triangular matrix as M of I comma J is 0 if I is less than J. M of I comma J is non-zero if I is greater than or equal to J. So these elements are non-zero and those must be 0. Now let us observe in the matrix of n cross n, that is 5 by 5, total 25 elements are there. Then how many elements are non-zero? So number of non-zero elements. First row is having one element. Second row is having two non-zero elements. Third row is having three non-zero elements. So this is for 5. So this is 4 plus 5. Now for any n cross n matrix, it will be 1 plus 2 plus 3 plus goes on to last one will be n. So this is n into n plus 1 by 2 number of elements are non-zero. These many elements are non-zero. In a matrix, total n square elements will be there, n square, and non-zero elements are n into n plus 1 by 2. So if I subtract this, then I get 0 elements. These are 0 elements. So non-zero elements are n into n plus 1 by 2, and 0 elements are n square minus n into n plus 1 by 2. So this will be n into n minus 1 by 2. So if you observe, here is 1 0, these are 2 zeros, then 3 zeros and 4 zeros. Dimensions are 5 cross 5, but the last number of zeros are 4. So this is going up to 1 plus 2 plus 3 plus 4. So that is n into n minus 1 by 2. So there are n into n minus 1 by 2 number of 0 elements and n into n plus 1 by 2 number of non-zero elements. Now let us talk about representing these lower triangular matrices in our program. So when we want to use them in a program, we want to avoid storing zeros so that we can save memory space as well as we can save the time in processing zero elements. Then for storing non-zero elements, how much space we need? There are n into n plus 1 by 2 number of elements, so we need n into n plus 1 by 2 amount of space. So as per our example, how much space we need? So we need 1 plus 2 plus 3 plus 4 plus 5, that is total 15 spaces we require. So let us see how it can be represented. So I will take an array of the size of 15 and we will learn how to store these elements. So here I have an array of 15 spaces of 15 size. Then I can store all these elements in this one. Now how to store these elements? One method is I can store them row by row, and second method is I can store them column by column also. So let us follow row by row method. We can call it as row major method. So first let us see row major method. So let us follow row major. I'll fill the elements row by row. First element, this is A11. So this is row 1. This is row 1. Then row 2, that is A21 and A22. So this is A21 and A22. So this is row 2. Then 31, 32, 33. So likewise I will fill up all the elements row by row. So here I have filled all the non-zero elements in an array row by row. Here one thing to observe is in this representation I have indices starting from 1 onwards, but as per programming, C or C++ programming, array starts from index 0 onwards. So we have to take care of it. So we have simply stored the element row by row. But is there any formula that is mapping this two-dimensional array, that is lower triangular matrix, in a single dimension array? Let us come up with some formula so that we can access a specific element. So let us see how we can build up a formula. See, suppose I want to access an element that is 4, 3. So 4, 3 is in 4th row, so this is here. So this element I want to access. If I want to access this element, reach this element, then what should be the index of A of 4, 3? What should be the index? 4, 3. So here it is 4, 3, but in this array its index is 8. So I should get 8. So for that, if I start array from index 0, I have to move 8 indices to access this one. So how to know how many indices we have to move? See, this element is in 4th row, this is 4th row. So this will come after 3 rows. So in first row, how many elements are there? Second row, how many? So I have to skip 3 rows. So first row is having just one element, then second row is having two elements, then third row is having three elements. So I have skipped three rows. Yes. So I have skipped three rows. Now, when I have skipped first row, second row, third row, I am here in the beginning of fourth row. Then how many elements I should move ahead to reach this 4, 3? So when I am here, I should move 1, 2. Two elements I should move. So plus 2. So if I take total, this is 8. So yes, I got the index. So this is for 4, 3. Let us take one more example and then we will build a formula. Suppose I want to access 5, 4. So 5, 4 is present at 13. So what should be the index of 5, 4? 5, 4 means I should go to 5th row. So for that I should cross over 4 rows. So first row is having one element and second is 2 and third is 3. Then fourth row is having 4 elements. So I have skipped first row, second row, third row, fourth row. Then I am here in the beginning of this one. Then from here, how many steps I should take to reach 5, 4? 1, 2, 3. So plus 3. If you add this will be 13. So yes, I got the index. So what is the formula for any I, j? So for any index a of I, j, formula should be, see, this is adding 1 plus 2 plus 3 because it is 4. This is adding 1 plus 2 plus 3 plus 4 because this is 5. So this means for 5 it is 5 into 5 minus 1 by 2. That is sum of n natural number that is less than 5. 1 less than 5. So 1 less than I. So this will be I into I minus 1 by 2. Then plus, see this was 3, so this was 2. This was 4, so this is 3. So if it is a j, then it will be j minus 1. So this should be the formula for accessing non-zero elements in a single dimension array. This is a row major formula. So we can prepare a program for this one using this formula. We'll be looking at all other matrices. Then finally I will show you one single program in which I will just change the formula so the matrix will be changing. So at the end we will see the programming part. Now let us see how we can represent them in column measure. That is, if I am storing the elements column by column. Now let us look at column measure formula and store the elements column by column in this single dimension array. So column measure formula. So I'll fill the elements column by column. So first column elements are 1, 1, 2, 1, 3, 1, 4, 1, 5, 1. So 2, 1, 3, 1, 4, 1, 5, 1. So this is column 1. Likewise, I'll fill up second column, that is 2, 2, 3, 2, 4, 2, 5, 2. So I'll fill all the columns. So I have filled all the elements column by column. So simply we have filled the elements column by column, but there must be some formula that is mapping these two-dimensional array elements or a matrix element in a single dimension array. So we need to come up with some formula. So for that, I'll take some examples and we will do some observation and then we will prepare the formula for it. Let us take an example of element a of 4 by 4. So this is a of 4 by 4 and here in this array it is present at index 12. So let us get the index 12 by observation, then we will prepare the formula. So the index of an element a of 4, 4. How to get the index? So first column, check for the column. Column is 4th, so I have to go in 4th column. So 4th column means I should skip how many columns? 3 columns. 3 columns I should skip. So first column is having how many elements? 5 elements. Then second column is having 4 elements. Then the third column is having 3 elements. I should skip all these columns. 5, then 4, then 3. Then afterwards, when I have skipped first, second and third column, then I am here in the beginning of this one. So do I have to move ahead to get on the element? No, I am on the element only. So this is 0. So total this is 12. 5 plus 4, 9. 9 plus 3 is 12. So this is 12. Next, I want the element that is 5, 4. That is in the same column, column 4. So let us get the index for that one. Index of A of 5 comma 4. So this is again in fourth column. So for reaching fourth column, this is column number 4, I should skip the elements, 5 elements, 4 elements, then 3 elements. So this is 5 plus 4 plus 3. Then when I have skipped first column, then I am here. Second column I skip, I am here. Third column I skip, I am here. Then how much I should move ahead? Just one element I should move forward. So this is 1. So this is 5 plus 4, 9, 9 plus 3, 12, 12 plus 1, 13. And I got the index 13. Let us take one more example and then we will try to prepare the formula. So let us take the example of 5 comma 3. This is in third column. So what is the index of 5 comma 3? 5 comma 3 is present here in the third column. So for that I should skip 2 columns. So the first column is having 5 elements, second column is having 4 elements, then plus. When I have skipped first column, I am here. Second column I skip, I am here. How much I should move ahead to reach that 5 comma 3? 1, 2. 2 places. 2 places. So this is 5 plus 4, 9, 9 plus 2, 11. Index is 11. Yes, I am getting it. Then how this can be converted into the formula for any index I comma j. So I will try to observe these values and write down. So if, for example, if I take this one, the column number was 4 and here also column number was 4. So this is 5. 5 is nothing but n cross n. So first one is n, then plus n minus 1, then plus n minus 2. For 4, this was n, then n minus 1, then n minus 2. Then for 3, how much it is? N, then n minus 1 only. So for 4, it was up to 2. For 3, it is just n minus 1, only 2 are there. So it means for 4, it was 2 times less. And for 3 also, it is 2 times less. So for any general form, this will go on till n minus, whatever the j value is, j minus 2. It will go up to j minus 2 times. So n, n minus 1, n minus 2 go on up to n minus of j minus 2. So this has finished within the bracket, then plus. What is this value? What is this value? See, this we got 0 because it was 4, 4. This was 1 because 5, 4. And this we got 2 because 5, 3. So if you observe, this is 5 minus 3 is 2. 5 minus 4 is 1. So this is 4 minus 4 is 0. So yes, it is I minus j. This is the formula. I can simplify this one and say that this n is j minus 1 times. So n into j minus 1. So from here, if you count, then it is 1, 2, 3 up to j minus 2 times. Then this 1 is extra. So j minus 1 times n. Then this minus 1 and 2 and 3 goes on to j minus 2. So this is inside the bracket. Then afterwards, it's I minus j. I can simplify it further and say n into j minus 1, then minus, this is sum of n terms till j minus 2. So this is j minus 2 into j minus 1 by 2. And this is within a bracket plus I minus j. So this is the formula for column measure representation, and later we will see how to write a program for this one. We have seen row measure formula as well as column measure formula. These two formulas are useful in upper triangular matrix. That will be our next topic. In upper triangular matrix, the formula will be similar, but instead of I, j, they will interchange. So I will become j and j will become I. So we'll see that in next video. In this video, I will show you how to implement a lower triangular matrix using row measure representation as well as column measure representation. So I am using the same project for matrices. Already I have defined a structure for a matrix having array of fixed size and n for dimensions. This is structure we have already used in diagonal matrix, so I am using the same one. So you should get the idea how we can modify the existing program to make it as a new program. Instead of writing the whole program from the beginning, I will modify this one. Now this matrix is going to be a lower triangular matrix, so we don't know the size. We cannot take a fixed size, so I have to take a pointer and I will create an array dynamically for a required size. So the first thing, let us create an array. Inside the main function, I have created an object of matrix M. Then here, I will take the dimension of a matrix from keyboard. So let us give a message and ask what is the dimensions. Enter dimension. Then scanf percentile d, we will take dimension in m.n. See, m is a variable of type matrix and m is having variable n, that is data member n, that is for the dimension. Now once we know the dimension, we should create an array. So m.a is a pointer for an array. Here I should allocate the memory from heap. For that I will call malloc function. Now the question is, what is the size of an array that we need? We already know the number of non-zero elements present in lower triangular matrix. We have already seen the formula, that is n into n plus 1 by 2. These many number of non-zero elements, and this should be multiplied with size of integer. This will create an array of required size for storing non-zero elements that are n into n plus 1 by 2. Now the array is ready. Now we should have the functions for storing an element and retrieving an element. So we should have the function for set and get. So already I have the body of these functions. I will implement set function. So set function will take a matrix and it will take I and j as the indices and the element x to be inserted. So what is the element to be inserted and where it should be inserted? So lower triangular will have the elements only if I is greater than or equal to j. So if I is greater than or equal to j, then only the element is non-zero. So we will store the element in an array of at a location I into I minus 1 by 2 plus j minus 1. This is the formula we have seen. There we will store the element. See, it's so simple. We have already seen in a diagonal matrix it was I minus 1, but now instead of I minus 1, the formula has changed. Rest of the things are same. So that's all in set function. Now let us implement get function. So in get function, it is taking parameters matrix I and j are the indices. We want an element from an index I comma j. So here also the same condition, if I is greater than or equal to j, then only we have non-zero element. So we will return an element from location I into I minus 1 by 2 plus j minus 1, same location. Otherwise, we will return 0, means the element is 0. If I is greater than j, then it is non-zero element, otherwise it is a 0 element. Now this is the display function already we have used for diagonal matrix. So here that time I wrote for loops starting from 0 onwards. Now let us make them from 1 onwards so that we can properly use the formula without changing the formula. So I and j both are starting from 1 and ending at n. Now here non-zero element will be if I is greater than or equal to j, and the element is at a location I into I minus 1 by 2 plus j minus 1. So this is the place from where you can get the non-zero elements, otherwise the element is 0. So that's all. Now inside the main function, I will try to read all the elements of a matrix from the keyboard, then display them. So for reading all the elements of a matrix, I will say printf enter all elements. Then using for loop, I should read all the elements of a matrix. So for that, I require variables I and j for running 2 for loops. So matrix has to be accessed using 2 nested for loops. So for I assign 1, I is less than or equal to m dot n and I plus plus. Then for j assign 1, j is less than or equal to m dot n and j plus plus. These are the two for loops. Now inside for loop, I will read a value in a variable percentile d ampersand x. For reading a value also I need a variable, so I will declare the variable. Then I should set a value in a matrix at index I comma j, and the value to be inserted is x. So I should set the value at that particular location in the matrix using the set function. So here I will declare one more variable x. Then after reading all the values, I'll give a line gap. Then I will call display function by passing matrix M. Now let us run the program. Here is an error. Member reference type struct matrix is a pointer. Yeah, here we have taken a pointer, but I am using dot operator. I should use arrow operator. And remember one more thing, as we are using malloc function, stdlib should also be included. So I have changed it to arrow m dot m arrow a. Let us run it now. Yes, it's successful. Now here it's asking for dimensions. So the dimensions are 4 by 4. So I'll just give 4. Now enter all the elements. I will enter the elements 2, 0, 0, 0. This is the first row I am entering. See, I am giving zeros also. Then 1, 3, 0, 0. Then 1, 2, 3 and 0. And the last is 1, 2, 3, 4. So I am giving all the elements of a matrix. See, I got the same matrix. So how this is working is, when I have entered 2, 0, 0, 0, so this for loop has executed for the entire row, and it has called 4 times. First it will read 2, then it will set it, then 0, then it will set, and again for remaining 2 zeros it will set. So it will set all the values here. See, these all 4 values are set by this scanf and set function, and this loop will repeat it for 4 times. The next row, again this loop will repeat for 4 times. So if you check this set function will store the value only if it is non-zero. If I is greater than 0, then only it will store, otherwise it will not store. So that's all. This is the implementation of lower triangular matrix using row major representation. Now I will quickly modify this and make it as column major representation. See what are the changes I have to do. First of all, this is the matrix structure. Let it be same. Then this set and get and display function will come to them afterwards. Here the matrix is created. Then enter the dimension. And the malloc, what should be the size of a matrix? It should be same. Then here suppose I want to create a matrix and display it, it should be same only. And I will be calling set function. So everything remains same inside the main function. What all I want to do in the main function, same thing I'll be doing. Then going to the set function. Inside set function, this formula will change. If you remember the formula for column major representation, the formula was n into, so this is m arrow n into j minus 1, yes, then plus j minus 2 into j minus 1 by 2 plus I minus j. This was the formula. So already I have explained you this formula. The same formula I am using it here for setting the values. Then I will copy this formula, and for get also I should use the same formula. Then in display also I should follow the same formula. Yes. Now the elements will be stored column wise. Whatever the way they may be stored, this set will store the values and display will display the values. See, if you look from the main function side, main function doesn't bother how the elements are stored and retrieved. Main function is giving all the elements and it want all the elements, so display should display all the elements. So who is storing them? Set. Who will display them? Display. So whatever the elements we have given, we should get back the same elements. Let us run the program. Oh, there's an error. See, here it is call by value, m is call by value, so it is a dot. So it's not arrow, it is dot inside the display function. Then here in get function also, it's not an arrow, it is dot. Actually, I copied this one. See, this type of problem arises when you try to modify the existing program. Then you may do some mistakes and you may get those errors. And sometimes these mistakes and these errors are very much time consuming. It may take a lot of time for removing them. So it's better you retype the program from the beginning. But if you are able to convert it error free, then it will save a lot of time. Let us run the program once again. Yes, it's running. There were two errors, I have removed them. Now the dimensions, I want to give dimensions as 5. I'll give the same elements, 1, 4 zeros, then 1, 2, 3 zeros, then 1, 2, 3, 2 zeros, then 1, 2, 3, 4, then one more 0, then 1, 2, 3, 4, 5. Yes, I got all the elements. Yes, they are stored properly by using this column measure formula. So that's it for a lower triangular matrix. We have seen both the implementations, so row measure as well as column measure representations we saw. In this video, we will write a C++ class for lower triangular matrix using both the formulas row measure representation and column measure representation. So I'm using the same project that I have used for diagonal matrix. So already a class for diagonal matrix is written here. So instead of writing a class right from the scratch, I'll prefer modifying this class for diagonal as a class for lower triangular matrix, because there are only few methods like constructors and destructor and set, get and display methods. So the changes are very few. So it's better you write the complete class from the beginning, but you should also experience how to modify the code. So I'm going to modify this class for lower triangular matrix. This class name diagonal should be changed to lower triangular. So then again constructor will also change and destructor will also change, right? Destructor name, and wherever the class name is used with scope resolution, that should also change. So I have to make changes at various places. So better I'll do what? Find and replace. I will select find and replace diagonal, change that diagonal to lower triangular. So I am giving in short that is lower tri. Replace all. Done. See, all these names have changed to lower triangular. Now this is a class for lower triangular, right? But the mechanism inside these methods is still for diagonal matrix. So let us modify those things. So let us check everything line by line. Class name is lower tri, okay. Data members are pointed to an array and dimension n, okay, perfect. Then this is a default constructor of dimension 2 by 2. Then what should be the size of an array? It should be 2 into 2 plus 1, that is 3 by 2, 6 by 2, that should be 3. So instead of directly writing value 3, I have used the formula. Then this is a parameterized constructor. So what should be the size of this array? Dimension will be n only. The size of an array will be n into n plus 1 by 2. As we have seen, there are n into n plus 1 by 2 number of non-zero elements. Then these are the function definitions. So they are all same. Then this is a set function. Set function, it will take indices I and j and a value x. So non-zero values will be present only at the indices I is greater than equal to j. And the elements are stored at that place using the formula I into I minus 1 by 2 plus j minus 1. Yes. Then coming to a get function that will return an element at a given index. Again, here also non-zero elements are present at index I is greater than equal to j, and the elements are retrieved from a location I into I minus 1 by 2 plus j minus 1. The next is display function. Display function will display entire matrix including 0 and non-zero elements. So non-zero elements are present only at I greater than equal to 0. And the formula for retrieving those elements is I into I minus 1 by 2 plus j minus 1. Yes. And one more thing, these for loops for a diagonal matrix I have taken them from 0 onwards, but they should be from 1 to n. This is better. And j also starts from 1 to n is better. So I have modified these for loops starting and ending index also. That's all, the class is ready. Now let us write on the main function. So for writing main function, first of all, I should know what is the dimension of a matrix that I want to create. So for that, I will take the input from the keyboard and say enter dimensions and C in D. Now once I know the dimensions, I can create a lower triangular matrix LM for lower triangular matrix of dimension D. So this will be calling a parameterized constructor of this class, and it will be creating a array of size n into n plus 1 by 2. So D will be set into n. Then in this matrix, I will take all the elements and I will store the elements and I will set the elements in the matrix. So for this, I will take some variable x. Then here I will say enter all elements. Then using for loop, I will read all the elements. Integer I assign 1 and I is less than or equal to d, the dimension that we have given, then I plus plus. Then next for loop, for integer j assign 1 and j is less than or equal to dimension and j plus plus. Then I will take an element into variable x and I will call the function lm dot set an element at index I comma j, and the element that I want to insert is x. Yes, this two for loops will take all the elements of a lower triangular matrix, that it will take 0 as well as non-zero elements. Then after that, I will say lm dot display. This will display all the elements. See, just now we have taken the dimension of an matrix, so we should also have one function inside this matrix. So I will add it at the end after display. We want to know the dimension. So say get dimension. This should be a function which should just return n. So if you at all we want to know the dimension, we can call this function. But here I have directly used d because already in d we have the dimension, so I am using d. Yeah, here it's asking for dimensions, so I'll give the dimensions as 5. Now enter all the elements. I will enter the elements as 1 0 0 0 5, that is 1 2, then remaining elements are all zeros, then 1 2 3 and the remaining elements are zeros, 1 2 3 4 remaining element is 0, then 1 2 3 4 5. That's all. So it is displaying all the elements. I am getting back all those elements by display function. So here you can see this is displaying all the elements. So I have shown it for lower triangular. Now you can modify the formula and write the formula for. Now let us convert this program by using column measure formula. Say this is for row measure formula, and the column measure formula I have to make changes at few places. See, column measure formula also the size of an array will be same, that is n into n plus 1 by 2. then for setting the value and getting the value as well as a display, the formulas will change. So this formula is for row major representation. Now for column major representation, if you remember the formula, it is n into j minus 1 minus j minus 2 into j minus 1 divided by 2 plus I minus j. This is the formula, and the same formula I should use it in get function as well as display function. So I will copy this and I will paste it here, and also in display function we should follow the same formula. That's it. Let us run the program and see. Dimensions it is asking, so I'll give the dimension as 4. I will enter the elements 1 0 0 0, then 1 2 0 0, 1 2 3 and 0, 1 2 3 4. Yes, I am getting back the same elements, that is 1 to 4. That's all. So I have shown you row major as well as column major formula, how easy it is to make changes. Once you have a good grip on the C++ programming, you can make changes, or you can play with the code like this. You can make changes at few places and quickly you can transform a program into some other program. Now for lower triangular, I have completed. Rest of the matrices, that is upper triangular or symmetric matrix, you have to implement them. Now for the rest of the matrices like symmetric matrix and upper triangular matrix or Toeplitz matrix and all matrices, you have to implement the programs, right? And if you face any difficulty, you can inform me. If I can provide you a help, or even I can give you a program if you are unable to do, or you can send your program to me. If there are any errors, you are unable to remove them. If there are any severe errors, then I can help you. That's all with this. Now the topic is upper triangular matrix. As you are already familiar with the lower triangular matrix, we have seen its representation. So let us finish this quickly. This is a upper triangular matrix. So non-zero elements are in the upper triangular part of this square matrix. So these are non-zero elements. These are non-zero. So if I observe indices I, that is row numbers, and j, that are column numbers, then which elements are non-zero? If I observe this is 2 3, 2 4, 3 4, I and j, I is less than j, 4 5, I is less than j, 4 4, I is equal, so 1 3, I is less than j. So I is less than or equal to j, elements are non-zero. Then which elements are 0? If I is greater than j. So M of, that is a matrix M of I comma j is 0 if I is greater than j, and M of ij is non-zero if I is less than or equal to j. This is how we can define a upper triangular matrix. Next, how many non-zero elements are there in this matrix? First row is having 5 elements, then next row is having 4, then 3, then 2, then 1. So this is 5 plus 4 plus 3 plus 2 plus 1. So for any n, it will be n plus n minus 1 plus goes on up to 3, 2, 1. This is nothing but n into n plus 1 by 2. These many non-zero elements are there. Then how many zero elements are there? Zero elements will be n into n minus 1 by 2. So already we have seen this in lower triangular matrix. So if you have not watched that one, you can go back and watch it. Now next, how to represent this one in a single dimension array. So we will not be taking a two-dimensional array and filling with these many zeros. So we want to avoid storage of zeros so that we can save some space as well as processing time. So let us take a single dimension array. So what should be the size of a array? Depends on number of non-zero elements, that is n into n plus 1 by 2. So here the size, example size is 5. So 5 into 5 plus 1 by 2, that is 15. So I need an array of size 15 for storing these non-zero elements. I will take an array of size 15 here. So here I have an array of size 15, the indices are from 0 to 14, and we will map this upper triangular matrix in a single dimension array. So what are the methods? Again, two methods are there, that is a row measure and column measure method. So let us fill the elements row by row. So first we will see row measure, and I will remove this one so that I can work out in this place. Row measure. I will fill these elements row by row. So if you observe first row A11, 12, 13, 14, 15 and 15. This is row 1. The next row 2, 2. So it's not from 2, 1 onwards, 2, 2 onwards. The next row is 3, 3 onwards. So like that, I will fill up all those rows. So this is how I have filled row 1, row 2, row 3, row 4, row 5. And the last row is having just one element. So one element is there. First row is having 5 elements. So 5 elements are there. So in this way, all these elements are stored there row by row. Now we need a formula. So for formula, let us take one example and observe it. As I already told in the lower triangular matrix video that those formulas will be useful here. So let us take one example and see. We will take the element a of 4, 5. So index of a of 4, 5. 4, 5 is present here in 4th row. So I should skip first row, second row, third row, then I can reach there. So let us skip these elements, then I can reach in the beginning of the 4th row. So first row is having 5 elements, 1, 2, 3, 4, 5. Then next row is having 4 elements, 4 elements. Next row is having 3 elements. Then after skipping these elements, I am here in the beginning of the 4th row. Then how much I should move ahead to reach this 4, 5? Just one element. Then total is 4 plus 5, 9, 9 plus 3, 12, then 13. Yes, index is 13, so I am getting the index. So this looks similar to column measure formula of lower triangular matrix. If you have not seen the video, go back and see that video. I'll directly use that formula here. So formula for any element at index ij. This can be written as, see, this 5 is nothing but n. This is a dimension n cross n or n by n. So this is n plus n minus 1. Then plus n minus 2. This is go on reducing. Up to what? See, this was 4. This was 4. So this was up to 5 minus 2. 5 minus 2. 5, 5 minus 1, 5 minus 2. So this should be I minus 2 up to I minus 2. N minus of I minus 2. Then outside this, see, this is 1. So this is 5 minus 4. J minus I. J minus I. So if you remember that formula, this is same as that formula, only I and J has interchange. I became J and J became I. So the final simplified formula can be I minus 1 times n minus I minus 2 into I minus 1 by 2, and finally J minus I at last, this one. So this is the formula for a row measure representation of upper triangular matrix. So these formulas, I'll be using them in the program afterwards. So once we finish the matrices, I will show you the program. Now let us look at column measure mapping of this one. So we'll store the elements column by column in a single dimension array. Then we come up with some formula. Now let us look at column measure mapping, storing our upper triangular matrix that is two-dimensional in a single dimension array column by column. So column measure. So column by column I will be filling the elements. So the first column is having just one element, that is A11. So this is column 1. The next column is having two elements, 1, 2 and 2, 2. 1, 2 and 2, 2. This is column 2. Likewise, I will fill up all these columns in this array. I have filled all the elements. Now we need a formula. For that, I will take one example and get its index, and from observation we'll get the formula. And already we have seen lower triangular matrix, and the formula will be similar to one of the formula of lower triangular. So let us take the example and then observe it. I'll take the example of 4, 5. So this is in fifth column and at index 13. So 4, 5. Index of element 4, 5. Now 4, 5, for reaching this element 4, 5, I should cross first column, second column, third column, fourth column, then I will be in fifth column. So I should skip over first column. How many elements in first column? Just one. Then second column, 2 elements are there. Then third column, 3 elements are there. Then fourth column, 4 elements are there. When I have skipped first column, I am here. Then second column, I am here. Third column, I am here. Then fourth column, when I have skipped, I am here. Then from here, how many spaces I should move to reach that 4, 5? 1, 2, 3. So 3 places. This is 1 plus 2, 3, 3, 3, 6, 6, 4, 10, then 13. Yes, I got the index 13. So if you observe, this looks similar to row major formula for lower triangular matrix. So yes, but I and j will be different. So let us prepare a formula for any index I and j. Index of any ij, this is 1 plus 2 plus 3 plus 4, up to 4 only because column number is 5. So it means column minus 1. So this will be 1 plus 2 plus 3 plus goes on to j minus 1. This is j minus 1. And this is a 3. So this is row minus 1. That is 4 minus 1. So I minus 1. So this becomes, this is sum of first and natural numbers. This is j into j minus 1 by 2 plus I minus 1. This is the formula. So we have seen row major as well as column major representation for upper triangular matrix, and we got the formula. Formulas are similar to the formulas of lower triangular matrix. So these formula we will use them, and I will write one program by using these formulas for lower triangular as well as upper triangular. So in our program we will use these formulas. Now we'll move on to the next topic, that is symmetric matrix. Now next topic is symmetric matrix. So here I have taken an example of symmetric matrix of order 5 cross 5. Let us observe the property of this matrix. See, these are row numbers and these are column numbers. The element at 1, 3 is 2 and 3, 1 is also 2. Element at 3, 4 is 4 and 4, 3 is also 4. So if you observe, the elements at location ij is equal to an element at location ji. So if matrix of ij is equal to matrix of ji, then it's a symmetric matrix. This is the property of symmetric matrix. This is the definition of symmetric matrix. Do we have to store all the elements of a symmetric matrix? No. If I store ij value, then I can retrieve ji also. So if I know any element at I, j, then also I know element at j, I. So it means if I know this element 4, 1, then also I know 1, 4. So it means it's sufficient to store either elements in the lower triangle or the elements in the upper triangle. Those elements will be sufficient. So if I know these elements, then automatically I can retrieve those elements also. So it means for storing a symmetric matrix, I don't have to take a two-dimensional array. I can take a single dimension array and store it. Then how we can represent this matrix? We can represent a matrix either just by taking a lower triangular part, or I can store only a upper triangular part. So a symmetric matrix can be represented as either lower triangular or upper triangular. Any of these two can be followed. And when we are looking for any element at I, j, we can also retrieve an element at j, I. Already we have discussed how a lower triangular matrix can be represented and how a upper triangular matrix can be represented. We can follow any of these methods. So we don't have to discuss further on this one. When we write a program, that time I'll explain you how we can utilize these. Yeah, our next topic is tridiagonal matrix. So here I have an example of a 5 cross 5 matrix, and it's a tridiagonal matrix. So what does it mean by a tridiagonal matrix? So if you look at the elements are there in main diagonal, then in the lower diagonal, then in upper diagonal, and rest of the elements are all zeros. So let us define the property of this matrix based on indices, row number and column number, that is I and j. So if you observe the indices of elements, the elements in the diagonal, they have I equal to j, I equal to j. And the elements in lower diagonal, 2, 1, 3, 2. So if I subtract I and j, I minus j, this gives me 1, this gives me 1 and 1, 1, yes. Then I minus j, this gives me minus 1, minus 1. So the elements in the main diagonal, they satisfy this property, that is I minus j is equals to 0 and I is equals to j, so if you subtract it is 0. Then lower diagonal, they satisfy the property, that is I minus j is equals to 1. And upper diagonal, they satisfy the condition, that is I minus j is equals to minus 1. If you subtract this, you get minus 1. So the elements whose row number and column number, that is indices, are satisfying these conditions, they must be non-zero and all other elements must be 0. So I can combine these three conditions together and write them as I minus j absolute value, that is mod, is less than or equal to 1. So if you subtract I and j, if you are getting a value less than or equal to 1, that is the absolute value, then those elements must be non-zero. So finally, I can say that m of I comma j is non-zero if I minus j is less than equal to 1, and m of ij must be 0 if absolute value of I minus j is greater than 1. So these elements, if you take the indices, if I try to write the index for this one, this is 4 comma 1. Subtract 4, 1, you get 3. So subtraction of I and j is greater than 1. So these elements are all 0. So this is the definition of a tridiagonal matrix. Then total, how many non-zero elements are there? See, 5 elements here, and 1, 2, 3, 4, 1 less than 5. 1, 2, 3, 4, 1 less than 5. So 5 plus 4 plus 4. So here I have 5 plus 4 plus 4 elements. So in terms of n, this is n plus n minus 1 plus n minus 1. So this is 3n minus 2 number of non-zero elements are there. So we have been trying to avoid storing 0 elements. So here also we go for same thing. We will avoid storing 0, so we'll store only non-zero element. Then we will not be taking a two-dimensional array for this matrix, we will take a single dimension array. What should be the size of that single dimension array? Depends on number of non-zero elements, that is 3 into n minus 2. So what is n in our example? 5. So 15 minus 2, that is 13. So we need 13 spaces for storing these elements. So let us see how to represent this tridiagonal matrix in a single dimension array. I will take an array of size 13. So here I have an array of size 13 for storing all non-zero elements. Then how to map these elements in a single dimension array? We have stored lower triangle and upper triangular matrices by following row by row or column by column. If we try here row by row, then first row is having 2 elements, then next 3, 3, 3, then 2. So rows are not having uniform number of elements. Likewise, columns are also not having uniform number of elements. Then one option we have is we can represent them diagonal by diagonal. So let us store the elements diagonal by diagonal. Which diagonal we should take first? We can pick up either the upper diagonal, then main, then lower, or first lower, then main, and then upper. So we have both options. So let us store first lower diagonal elements. I will store lower diagonal elements. 2, 1, 3, 2, 4, 3, 5, 4. So first I will store this lower diagonal. Now likewise, I will store main diagonal elements and upper diagonal elements. followed by that. So I have stored all three diagonals. Now how to map these? There must be some formula. So we cannot come up with a single formula for all the diagonals. We have to handle them separately. So simply we will go diagonal by diagonal. So first, if I want the index of any element, that is a of I comma j, then first case 1, if I minus j is equals to 1. So it means these are lower diagonal elements. If I minus j is equals to 1 means lower diagonal elements. Then if I is given as a 2, then it is at 0. If it is 3, then it is as 1. So it's a difference of I minus 2. The elements are at I minus 2. So the index is I minus 2. So if I is 2, then it's at 0. If I is 3, then it's at 1. If I is 4, then it's at 2. So I minus 2. Or else we can also take j minus 1 also, but better represented using I. Then case 2, if I minus j is equals to 0 means we are looking for main diagonal elements. If it is a main diagonal element, then first of all I should cross over lower diagonal element. So how many elements are there in the lower diagonal? We have n minus 1 elements in lower diagonal. Once we cross these n minus 1 elements, we are here. In our example, n is a 5, so 5 minus 1, 4, so we are here. So if suppose you want 1, then don't move at all. If you want second element, I is 2, then move 1. I is 3, then move 2 spaces. So it's I minus 1. N minus 1 plus I minus 1. This will be the formula for elements of main diagonal. Then case 3, if I minus j is equals to minus 1, that is the elements of upper diagonal, then I should skip these elements and these elements. So n minus 1 and n elements. So index will be 2n minus 1. So I have to skip all these elements, then I'll be here. And that location can be taken as 0. So if I want 1 comma 2, then don't move. That is the element. If I want 2 comma 3, then move by 1 place. So if it is 3 comma 4, move by 2 places. So that is I minus 1. So if you want 3, then move by 2 places. So again, this is also I minus 1 plus I minus 1. So we have 3 different formulas for mapping a tridiagonal matrix in a single dimension array. So that's all about tridiagonal matrix. We will write a program for tridiagonal matrix. Now I will also show what is square band matrix. A square band matrix. Square band matrix is similar to tridiagonal. In tridiagonal, only 3 diagonals will be there: main diagonal, lower and upper. But in square band matrix, there is a main diagonal, and below main diagonal there are more than 1 diagonals, like 1, 2, 3, and there can be more. And above main diagonal also same number of diagonals are there. So it's forming like a band of diagonals. So when there are more than 1 diagonals below main diagonal and we have equal number of diagonals on both the sides, then it is called as square band matrix. And a square band matrix, if it's a very big matrix, then again you may have a lot of 0 elements depending on the size of a matrix. I have taken an example of 8 by 8 here. Suppose it's 100 by 100 or 200 by 200, but I have only 3 bands below main diagonal, that is, this is the main diagonal, and 3 bands below this one or 3 bands above that one. Then a lot of elements will be 0. So then we prefer storing only non-zero elements. Then same way you can take a single dimension array and you store diagonal by diagonal. So just I have given the introduction about this one. So this is a square band matrix. So our next matrix is Toeplitz matrix. Next matrix is Toeplitz matrix. So this is a Toeplitz matrix of order 5 into 5, 5 cross 5. Let us observe the matrix. This is having all non-zero elements. Then what is the property of this matrix? So if you observe, the elements in a diagonal are same. all numbers are same. And the elements in lower diagonal are same. Okay, these are also same, these are same. Upper diagonal, again they are same, these are also same. So elements in a diagonal are same. So it means 5, 5 element is same as 4, 4. That is same as 3, 3. So from bottom I have started. Then if I take this element 5, 4, that is same as 4, 3. See 5 minus 1 and 4 minus 1, 3. So it means that if a matrix is having elements such that M of ij is same as M of I minus 1 and j minus 1. So this element is same as this one, this is same as this one. So which is the original element? This is the original element, we can say. This is the original element for this one, this is the original element. So when the elements are repeating, there are duplicated and there is some pattern followed, that this is the pattern followed. Then we don't have to store all non-zero elements. Then how many elements are sufficient? It is sufficient to store a row of elements and a column of elements. This is sufficient. And this is a common element, so we have to store only first row and first column. Then how many elements are there? See, elements, if I take, first row is having n elements, that is n, that is 5. Then column, I don't have to take this again because this is common, so this is n minus 1 plus n minus 1 elements. So only these many elements are sufficient. So let us see how to represent this one. So I'll take an array and store all these elements. So what should be the size of an array? Size of an array should be 5 plus 5, 10, 10 minus 1, 9. So I will take an array of size 9. So I have taken an array of size 9. Now how to represent these elements? So I don't have to store all the elements. First I will be storing first row element. Then let us store column elements. That is sufficient. So first row elements 2, 3, 4, 5, 6. So 2, 3, 4, 5, 6. This is row. And first column element 7, 8, 9, 10. So these are 7, 8, 9, 10. And this is column. So mapping of these elements I have done. Now what should be the formula for retrieving the elements? See, if the elements are in the upper triangular part, means these elements that are in a row here, and these lower triangular elements, they are in a column. So how do you identify the elements here? So here the indices are such that I is less than j, but including diagonal. So I is less than equal to j, it means the elements are of this upper triangle. So for any index of an element a of I, j, then the formula we can come up, case 1 is if I is less than or equal to j, means the elements in upper triangle. So for example, I want 3, 4 or 3, 5, 2, 3, 2, 4 or 2, 5, any of these elements. So 2 is smaller than 3, 4, 5 and all. So 2 is smaller than 3, 4, 5. So that's what I is less than equal to j means the elements are in upper triangular part of a matrix. So they belong to a row. So I should get an element from here. So I'll take some examples and show you. Suppose I want an element at a of 2, 4. So 2, 4. 2, 4 is 4, that is 3, and that 4 is present here at 2. So how I can get the index? So let us subtract 4 minus 2, that is 2. Then what about the element that is 3, 4, that is 3, and this one 3, 4. So 3, 4, the element 3 is at 1. So let us do 4 minus 3, it is 1. So it means if I subtract j minus I am getting the index. So for case 1, upper triangle, how we should retrieve an element? What should be the formula? See, these are all diagonal elements. So diagonal elements means I minus j is equals to 0. So yes, this element 2 is present at 0. Then these elements 3, 3, 3, this is I minus j. If I do, this is minus 1. And the element is 2 and it is at index element is 3 and it is at index 1. So yes, 1. So this I am getting minus 1. So let us make it as j minus I. So this is plus 1. Then these elements, that is 4. So if you take j minus I, this is 2. So 2. So the element is 4. So it is present at index 2 only. So this means I can obtain the index of any element in this array by doing j minus I. So yes, index is j minus I. That's it. Then second case, what about the elements that are in lower triangle? So case 2, if I is greater than j. So these elements. Then if I want this element 7. So if I do I minus j, this is 1. And here I minus j is a 2. I minus j is a 3. So this is 1 and 3. The elements of this diagonal are 1, that this diagonal is 2, this diagonal is 3. Now let us observe there where it is, starting from 5. So first of all, I have to leave all the elements of this row, then I can go there. So index will be n plus. So leave 5 elements. Once we leave 5 elements, we'll be on 5 and this should be 0. Wherever you are now, that location treat it as 0. So if we are here, let us call it as 0. So that 0 means here we get the index as 1. So minus 1 we can do. So this is I minus j minus 1. So this is the index for lower triangular elements. So that's all about Toeplitz matrix. So we'll write a program and we will write a program for Toeplitz matrix. I'll be discussing the program. So let us write a menu-driven C program for the matrices. So first I will show a program for one of the matrix, then I will show you how changes can be made in the same program for making a program for other matrices. So what my program is going to do is, it's a menu-driven program. So first option is creating a matrix. Second one is getting a particular element at a given index. Then set is for changing an element at a given index, then displaying that matrix. So let us write a program first for diagonal matrix. So I will write a complete program for diagonal matrix. So here is the starting point, that is main function. What are the variables I need? So initially I will take few variables, later on if required I will add more variables. So first of all I need an array for storing the elements. So for that I will take a pointer, integer star a, because I don't know how many elements are there. So I'll take the dimension, then I will create an array dynamically. So I am taking a pointer. Then n is the dimension. So diagonal matrix is a square matrix, so we need n cross n, so just one value n is sufficient. Then for choice, I may need some variable ch for choice, taking choice 1, 2 or 3 or 4. Then I need some variable maybe for reading the value, so I'll take one more extra variable x if at all required. The first thing, program should ask what is the dimension and create an array. So let us write a message, printf enter dimension, and scanf take the dimension in n, ampersand n. So here we got the dimension. Now next thing, I should create an array in a heap and assign to a. So a assign. How to create an array in heap? Malloc function, malloc. So what should be the size of an array? Size of an array for a diagonal matrix is n. Whatever the dimension is, that many elements are there. So n elements are there, only n elements in a diagonal. So n into size of integer, because this is an integer array, so size of int. So this may be a 2-byte integer or 4-byte integer, whatever the size of an integer is, that size is taken. And I should typecast the pointer of type int. So this will create a array in heap for this size n. So using malloc, we can allocate the memory in a heap. This is in C language, but in C++, a simple operator is given that is new for creating an array in a heap. Like we can simply say A assign new integer array of size n. So instead of this lengthy syntax, we can allocate a heap memory like this. So next time onwards, I may not be using malloc function for creating anything in a heap. I'll be using new. This is simple. Though while writing the program, I will be using malloc function, but for explanation on board, I will be writing new. Now next thing, program should display a menu, and that menu should be repeatedly available. So let us write down this whole code in a loop, that is do while loop. In the beginning, it should display the menu. So I will say display menu. So using printf, we can display this one. So 5 to 6 statements I require for displaying the menu. So I'm not writing that code. Then after taking the menu option may be 1, 2 or anything. So that can be processed in switch case. Switch based on the choice that is given. The choice, whatever the choice, suppose we are taking in ch. Then if case 1 is create an array. So creating an array means I should take all the elements and fill those elements in an array. So if I show you diagrammatically, we have a pointer A and to which an array is created and attached to it. Suppose the dimension is 5, so we have an array of size 5 held by a pointer. So this array has to be filled. So in a diagonal matrix, how many elements are there? Just n elements are there. So I have to take all the elements one by one and fill them in this array. So shall we take the 0 elements also or only non-zero elements? We should take only non-zero elements, and it is obvious that we have to enter them row by row, means all the elements in a diagonal. That is the first element, the next element, the next, the next. So in the same order it should be filled. So for simply reading n values, so I will take I starting from 1, I is less than equal to n, I plus plus. See, in the matrices, we were saying that the indices are starting from 1 onwards. So that's why I am taking from 1 to n. So the indices will be 1 to 5. Row numbers will be 1 to 5, column numbers will be from 1 to 5. But the array indices starts from 0 onwards. Anyway, we know this formula, that is I minus 1. There we have to save it. So we can say scanf percentile d ampersand a of I minus 1. So the first row element will be filled in this one, then next row here. So all these elements will be filled. So it will be reading 5 elements and storing them in a single dimension array of size 5. This is for creating an array. I did not write any message here. I can write a message, enter the elements row by row. Or I can say enter all the elements in a diagonal one by one. Then I can read all these values. So this is first case, that is taking the values. Now second case, getting a value from a given index. So here I can say printf enter indices. Then scanf percentile d, I should read I and j. Row number and column number, both I should read. Then after reading this one, if I is equal to j, then for this there is a non-zero element available. So in the same line I will say printf percentile d. Which element I should print? I should print an element from I minus 1. That's it. Else that element is 0. So I will print just 0. So whatever the element you want to retrieve from that two-dimensional matrix, you can mention indices. If it is a diagonal index, then we get a non-zero elements. If it is not a diagonal index, then we will get a element 0. So two cases are over. Now there is no space, so I'll continue here. Case 3, that is for setting an element at a given index. So I have to take 3 things: row number, column number, and element also. So printf enter row, column, and element. I will read 3 things: scanf percentile d, percentile d, percentile d. ampersand I, ampersand J, ampersand X. So I'll be reading three values. Then if the indices are for diagonal, then you change the element, otherwise don't do anything. So here I will write down the condition, if I is equal to J, then in the same line I will continue, set the element at I minus 1 as the given element X. So suppose I want to change this element or this element, so whatever the element is already present there, suppose 6 was there and I want to change it to 10, so you can change it. So this is a row 1, row 2, row 3. So I have to give row 3, so it is I minus 1, so at a 2 it will change. This is for case 3. Then break. Then the last option, display. Displaying the complete diagonal matrix. I want to display it as a matrix only, that is two-dimensional. So for a two-dimensional, I have to use two nested for loops. So let us write case 4. So first for loop, for I assign 1, I is less than equal to n, I plus plus, and for j assign 1, j is less than or equal to n, j plus plus. So I have two for loops. Then inside this, I should print an element only if it is a diagonal element. Otherwise, I should print a 0. So here I will write on the code for that one. So I have written complete code for displaying. I am displaying an element if I is equal to j, otherwise I am printing 0. Then after every row, this is /n, that is a new line. Then the next thing is, I have started with a do, then I should close it here with a while. So there is no space, so we will see this when we write the program. So here we are getting the idea how we should write a program. Explanation of a program I am doing here. So this is for diagonal matrix. So in a diagonal matrix, we have created an array and reading an array and getting the value and setting the value and printing a matrix. Now we have finished for diagonal matrix. What about lower triangular matrix? We have different formulas for row major representation and column major representation. Different formulas are there. Now the program will be similar only. We want to create an array of required size, and then program will be having these four options: creating an array and filling the elements, then getting an element, setting an element, and displaying a matrix. So same options I want to provide. Now for lower triangular also, I want to provide same options in a program, so the working of a program will be same, but it will be for lower triangular matrix. So in a lower triangular matrix, there are two formulas, row major and column major. So if we take row major formula, then here the formulas will change. So in the same program, as we have already seen the program, what are the changes I should make in this one so that it becomes a program for lower triangular matrix using row major formula. So I'll simply make the changes in the program. Main function as it is, and also I was using variables like I and j, so I will declare them. Now take the dimension n. For a lower triangular matrix, how many non-zero elements will be there? If you remember, it will contain n into n plus 1 by 2 number of elements. So this size of an array which is created, I'll remove this one and I will write a C++ code here. New int of size n into n plus 1 by 2. That's all. So the size is different. Array size is different. That is n into n plus 1 by 2. Then here a menu is displayed. Then the switch case, first choice, creating a array means entering all the elements. So after creating an array, then inside the menu, here I have to read the elements. So for reading the elements, I can read all the elements 0 as well as non-zero and store only non-zero elements. So for that, I have to write on the code. So this I'll be showing while writing the program. So I have to write two for loops and take the elements. If the element is non-zero, then using the formula, I should store the element. And if it is 0, just I should skip it. Then get function, get, I want to get the element. So when I can give an element, if I is greater than or equal to j, then it is lower triangular element, that is non-zero element. If I is greater than or equal to j, then we have an element. So from where I should take an element? I should take an element from I into I minus 1 by 2 plus j minus 1. I'll remove this one. So from this place, that is, I am using the formula. By using the formula, we can retrieve an element, get an element from a given index. Then if you want to change an element at a given index, then this is for set. Then here also, if I is greater than or equal to j, then from where I should change the value? So I should change the value at I into I minus 1 by 2 plus j minus 1 assign x. That's how I can change the value. Then for display, whenever I is greater than or equal to j, we will get an element, and again here the formula will be I into I minus 1 by 2 plus j minus 1. That same formula. So you can see that by changing the formulas at few places, the program changes for lower triangular matrix. So I have shown only for row measure. Now same way we can implement for column measure and also upper triangular and two methods, and finally for symmetric matrix and other matrices also, tridiagonal and Toeplitz matrix. So for all the matrices we will follow same approach. So I have given you the idea how a program should work. Now based on the same idea, I will be writing the program. For writing the program using functions, I'll give you the idea how a program can be written. The menu for the program will be same. It will be creating a matrix and changing the element, reading the element, as well as displaying the element. So how the program should look like? This is a main function for a program. Main function is having an array for storing the elements. So for that I will take a pointer. Then n is the dimension. Then rest of the things whatever required we will see. Then inside this I should create an array. Take the dimension first of all, then create an array of required size, new int of size n for a diagonal matrix. And for this n into n plus 1 by 2, this also n into n plus 1 by 2, then followed by that the other matrices, whatever the number of non-zero elements, that size should be mentioned. Then the program should have a do while loop and menu options and everything, cases. Here we should have a switch case and write down the cases for each case. We should call a function. Then how the functions should be written, I will write on the prototype of those functions and show you. First function is void create. This create function needs array and the dimension. So it needs basically an array where it has to store the elements. So this main function should pass an array to that one. So this should take an array. I will take the name as A or X, any name you can take. So okay, better take the name as A only. It needs an array. This is how we can take array as a parameter. We can give square brackets also, or even we can use pointer as a star, as an asterisk. The next, for creating an array we need the dimension. Whatever the matrix may be, we need dimension. So based on the dimension we will read that many elements. So this needs dimension. So let us call it as n only. Then this will be reading the elements by using two for loops. So how to call that one is create pass array A and n. Now the logic for reading, now the code for reading the elements, we will be writing it. The next, we should have a function for getting an element from a given index. So for that, function name is get. It also needs an array. From which array? Okay, so that array we have to pass from here. And whatever the name you want, you can take it. So let us take it as X or A, any name you can give. That is a pointer pointing to this array. So how it looks like is, suppose this is an array. A is a pointer pointing to it. Then we pass this as a parameter. So this X will be a pointer pointing to this one. Or that A is a pointer that is pointing to this one. So you can use any name that is belonging to that function. Then what more we need? What are the indices? I and j. So this will read the element from that particular index and returns the element. So it should have the return type as integer because we have integer elements only. This is for get. Then what about the dimension? If you think that the dimensions may be wrong, you want to test them whether the dimensions are perfect or not, then you have to pass n also to that one. The next is set function. For set function, it needs array, pointer to an array, integer I, integer j, that is indices, row number and column number, and also x, the element that you want to set. And this is void. So the body, we will be implementing it. So already we have the idea how the body should look like. So I'm just writing the prototype of a function. So while writing the program, I will be expanding that one. Then the last function is display, void display function. It also needs array and it needs dimension. What are the dimensions? So that it can display an array of that dimension n cross n. So these functions will implement, and this will have menu, and it will be calling those functions, whichever function it wants. So this is how the design of a program looks like. So in the following videos, you will find the program for all these type of matrices, and all those programs will be following this approach. So I have just discussed the approach here, how those programs are working. So this is the class definition. I have just reduced the size. Now we will pick up the functions one by one and implement them for a diagonal matrix. Then simultaneously I will show you how changes can be made for writing other matrices. So here remember that we are just looking at how the program should look like, but writing the actual code, I will write the code and show you. So let us pick up the first function, that is constructor. So constructor, for implementing it outside the class, then write the class name and the constructor name. The parameter is dimension n. This will take the dimension of a matrix n cross n, so 5 or 6, whatever the size is. As per our example, it was 5. So this 5 should be set in this one, this value should be set in that one. So the member of a class can be referred with this operator. So this arrow n, assign n. So this keyword we can use for accessing the member of a class, and this n is a parameter. So if you are aware of this, that this is a pointer to an object itself. So this we can use if there is a ambiguity in name. See, this, the local member is n and the parameter is also n. So if both the names are n, so I cannot write n assigned n. That is meaningless. So this n means the member and n means local variable. So I have taken a size. Then for that same size, I have a pointer here. So I should create an array in a heap of that size. Suppose size 5. Then I should create an array in heap. So a assign new int of size n. So I can simply take either this n or this n. So if I want to write this, then I should say this arrow n or just n. So this will create an array. This is a constructor. So inside the constructor, this is created in heap dynamically. So simultaneously, I will show you the destructor also. So if I am implementing this destructor, class name, destructor name, then what a destructor should do? If a class is acquiring anything at runtime from heap, it should release that one. Or if an object is acquiring any resources, it should release the resources. So heap memory is a resource. So when we said new in the constructor, then we should say delete in destructor. Delete this a, but it is an array. So okay, mention the subscript operator for an array. This is what we need. So I have finished with constructor and destructor for a diagonal. Now I have to pick up the next function. But before picking up the next function, I will explain something about other matrices. If it is lower triangular matrix, then what will be the change? Definitely the class name and the constructor name will differ, but apart from that, what will be the change in the code? See, here we are creating an array for a diagonal matrix that is equal to size n. But in a lower triangular matrix, what will be the size of an array? The size of an array is equal to number of non-zero elements. So the non-zero elements are how many? N into n plus 1 by 2. These many elements are there. So here, if I am writing the code for lower triangular matrix, then here I should write n into n plus 1 by 2. This is the change. Now, depending on the matrix that you are writing, you have to allocate the space, so use that formula for the space. That's it. It's simple. Class name is related to the matrix and this will change. And the destructor you must write, dimension you must take, everything is same. Only here the formula will change. Now you get a space sufficient for storing all non-zero elements from a lower triangular or upper triangular or Toeplitz or tridiagonal, any matrix. So you give the size required for storing all non-zero elements. So this is the size. Next, I have to implement create function. So I will pick up create function. I will remove this and implement create function. For create function, return type is void and the class name diagonal and then the function name create. So I am saying that create means reading all non-zero elements and filling them in this array. But actually it is for diagonal matrix. Yes, diagonal matrix. Suppose it is 3 cross 3, then this will have some element here. Let us say 6 and 0, 0 and 0, 5, 0, 0, 0, 9. So only diagonal elements are there. What about rest of them? They are 0. Shall we read those also? So let us read it just like a matrix, a two-dimensional matrix, and store only those which are non-zero. Rest of them we know they are 0 only. Just ignore them, take them and ignore them. So I will write down the code for reading this entire matrix. So for that I need two for loops. For I assign 1, I is less than equal to n, I plus plus. Why 1 onwards? See, usually in for loop we start from 0 onwards. But if you remember, the matrix indices we have taken them from 1 onwards, right? For any matrix, we have started the indices from 1 onwards. So that's the reason I am starting from 1. Then, next for loop, for j assign 1, j is less than equal to n, j plus plus. Then read the value in some variable. C in, let us take it in some variable. So I need one variable here. Now, this value will be non-zero only if I and j are equal. Otherwise, it is a 0. So I should check the condition that if I is equal to j, then in a of I minus 1, see this is the formula. I minus 1, this is the formula, assign x. Otherwise, don't assign anything, that's all. So this is how I have written. See, one thing here. I am trying to take all the elements of a diagonal matrix, zeros as well as non-zeros. So I want the user of my program to feel as if he is entering entire matrix, complete matrix, all the elements. My program is deciding whether to store or not to store by checking the condition that if I is equal to j, then store the elements, otherwise don't store, just ignore it. Take the value but don't store it because the other values are zeros. This is how I have framed the procedure. If you feel that no, we should take only non-zero elements, then just using single for loop you can read all non-zero elements from 1 to n. You can read all the elements. So you don't need to for loop and you don't have to check the condition. Simply take only non-zero elements. So that's your choice. While writing the program, I will write the code only for reading non-zero elements and show you. But here the feel is, one is entering the complete matrix. Then you may be thinking that why one should enter zeros also. Yes, that's what I am saying. If I think that I should not waste the time of the user, let us take only non-zeros. Now, with this, I can explain you other matrices easily. If this create function is for lower triangular, then everything will be same. Number will be non-zero, element will be non-zero, only if I is greater than or equal to j. So only say I greater than or equal to j. And here I should store the element where? In the formula. And what is the formula for a lower triangular matrix, row major formula? That is I into I minus 1 by 2 plus j minus 1, assign x. So I'm using the formula and storing the element. This is for row major formula of lower triangular matrix. That's it. So the code is same, only the formula changed. Now this code became for lower triangular matrix, where the array size will be larger, not this one. Then change the formula, it becomes a column major. So only at some places you have to change the formula, otherwise rest of the code will be same only. Now get and set functions are simple functions just for setting the value and getting the value, similar approach. So directly while coding we will see. Now display function I will show you. So for displaying I want to display it as a matrix only. So again for all the elements of a matrix we need two for loops. So already I have two for loops. So let us change the name of this function as display. I will not need this variable. Then remove this one. Then two for loops. What is the purpose? Printing. So for that I will say cout. So for a diagonal matrix, say cout a of I minus 1. When? If I is equals to j. Otherwise, if I is not equal to j, then else cout 0. Give some space also. Here also I should give some space, so that space is given in between every element. That's it. Then after the first for loop, say cout and L. End of two for loops and the function call. So this code will print the matrix and it will print complete matrix with all the elements, zeros as well as non-zeros, everything it will be displaying. Now again, instead of showing just non-zero element, I am showing zeros also, that is coming as a print on the screen. This is for diagonal matrix. Then what about lower triangular when row major formula is used? Everything will be same. Here the condition will be I if I is greater than equal to j. The elements are non-zero. Then for printing, I have to use the formula cout a of. How to retrieve the elements? How the elements are mapped? That is I into I minus 1 by 2 plus j minus 1 and some space after the element. That's all. Now this code became a code for lower triangular matrix. So we have implemented all the function except get and set. I did not show that. So that's a simple function that storing a value and retrieving a value. We will see that while writing the code. So in the following videos, you will find the classes and the main function for all the matrices one by one. So in the following videos, I'll be showing you a complete program, a menu-driven program, which allow us to access all these options, either create or display or set the value or get the value. I will write menu-driven programs for each and every matrix. And you can see that all those programs look similar, only the formula will be changing. So I have given an overview of all the classes or the programs that I am going to show you. So that's all.